So, you're thinking about data science. That's fantastic. It's a field where curiosity meets impact, where you get to be a detective and a storyteller all at once. But maybe you're standing at the starting line, looking at this vast landscape of terms like machine learning, algorithms, and big data, and it feels overwhelming. The truth is, the journey isn't about being a genius from day one. It's about having a clear map and taking the first step with confidence. The most common hurdle for beginners isn't the complexity of the concepts, it's the lack of a clear starting point. The internet is flooded with advice, tutorials, and roadmaps, each pulling you in a different direction. But what if we could simplify it? What if we could boil it down to the essentials? We're going to focus on the foundational skill that turns abstract ideas into tangible results: coding. Think of it as learning the grammar before you write a novel. It's the tool that lets you actually do data science. This guide is for the absolute beginner. No prior experience needed. We'll start with the basics, walk through what to learn, why it matters, and how to practice it effectively. The aim is not just to teach you commands, but to help you build an intuition for solving problems with code. Data science is fundamentally about asking questions of data and finding answers, and that communication happens through code. By the end of this, you won't just know about data science, you'll have taken the first concrete steps toward becoming a practitioner. Let's begin. You might have heard that data science is all about statistics, mathematics, and business knowledge. That's true, but coding is the engine that drives it all. Without code, your understanding of a statistical model remains just an idea. With code, you can build, test, and use that model on real data. Coding transforms you from a spectator into a creator. Data lives inside computers, stored in databases and files. To work with it, you need to speak the computer's language. This is where programming languages come in. For data science, two languages stand out: Python and SQL. Python is your versatile, all-purpose tool. You'll use it for cleaning data, analysis, building models, and creating visualizations. Its syntax is clean and readable, making it beginner-friendly. SQL, or Structured Query Language, is the language of databases. You'll use it to retrieve, filter, and aggregate data from massive storage systems. Why not just use Excel? Spreadsheets are great for small datasets, but they have limits. Code is scalable and reproducible. A script you write for 1,000 rows can often work just as well on 1,000,000,000. Code is reproducible. You can rerun your analysis, share it, and get consistent results. This reproducibility is the bedrock of good science and reliable business insights. Python and SQL together unlock nearly any data task you'll encounter. Mastering them is your ticket to real-world data science. Let's dive in. Let's start your Python journey. The goal isn't to become a master overnight, just to learn enough Python to be dangerous with data. Start with the fundamentals: variables, data types, lists, and dictionaries. These are your basic building blocks. Lists are ordered collections. Dictionaries are key value pairs. You'll use them to organize your data. Next, control flow, especially loops. Loops let you perform the same action on every item in a list, saving you time and effort. Functions are reusable blocks of code that keep your programs organized and efficient. The real magic of Python for data science comes from its libraries. NumPy is the foundation for scientific computing, giving you tools for working with arrays and matrices. Pandas is the powerhouse for data manipulation, offering data frames, flexible tables for loading, cleaning, and analyzing data. For visualization, Matplotlib and Seaborn let you create charts and graphs directly from your data. These libraries turn raw numbers into compelling visual stories. You don't need to reinvent the wheel. Use these tools to accelerate your learning. Focus on mastering these basics and libraries. With them, you'll be ready to tackle real data problems. Let's get coding. Python is your workshop, but SQL is your key to the warehouse where data is stored. Most companies keep their information in structured databases, and SQL is the universal language to access it. SQL is more straightforward than Python. It's declarative. You describe what data you want, not how to get it. Start with select to retrieve data, and where to filter it. These two commands form the backbone of nearly every query. Next, group by and aggregate functions like count, sum, and avg let you summarize data for insights. Joins combine data from multiple tables, and subqueries let you perform multi-step logic. Mastering these concepts lets you extract exactly the data you need, no matter how complex the database. SQL is a must-have skill for any data scientist. Start practicing simple queries and build up from there. Reading about coding is one thing, internalizing it is another. The bridge is hands-on practice. Projects integrate everything you've learned: Python, Pandas, visualization, and SQL. You'll encounter errors and get stuck, but that's the essence of learning. Platforms like Kaggle and DataCamp offer beginner-friendly datasets and guided projects. Start with the Titanic machine, learning from disaster competition on Kaggle. Predict which passengers survived based on their data. It's small, manageable, and covers data cleaning exploration and basic modeling. Practice using pandas to explore Matplotlib to visualize and build a simple model. Move on to other datasets. Netflix shows COVID-19 trends anything that sparks your curiosity. The key is to pick projects that interest you. When you're curious, the work becomes play. Start building now. As you complete projects, don't let them sit on your computer. Showcase them on GitHub. GitHub is your professional portfolio, like an artist's gallery. A well-curated profile is often more impressive than a resume. It provides concrete evidence of your abilities. Anyone can claim skills, but your code proves it. Hiring managers can see your code, your questions, your charts, and your conclusions. Start simple. Create a free account, make a new repository for each project, and include your code and a README file. The README explains your project, dataset, steps, and findings. Don't wait until you're an expert. Start uploading from your first project. Consistent activity shows growth and motivation. Clean up your code, write a clear README, and push it to GitHub. Your future self will thank you. Make it a habit from day one. Build your portfolio as you learn. To work effectively, you need the right tools. The most important is an environment for writing and running Python code. Jupyter Notebook is the industry standard. Jupyter Notebooks let you combine code, visuals, and text in one place, perfect for exploration. Google Colab is a free browser-based way to start with Jupyter, no installation needed. GitHub isn't just a portfolio, it's also for version control. Learn the basics as you go. Spreadsheets like Excel or Google Sheets are still useful for quick inspection and sharing results. For larger projects, try a code editor like Visual Studio Code. Master these tools early to smooth your transition from learner to professional. A structured plan makes learning manageable. Here's a simple roadmap for your first 6 months. Months 1, 2, master the fundamentals Python basics and SQL queries. Use FreeCodeCamp or Kaggle's micro courses. Spend 70% of your time on Python, 30% on SQL. By month 2, you should write simple scripts and basic queries. Months 3, 4. Learn key Python libraries Pandas, Matplotlib, Seaborn, NumPy. Do tutorials with real datasets. Try Coursera's IBM or Google Data Analytics certificates for structured projects. Aim to load data into Pandas and perform exploratory analysis. Months 5, 6. Focus on building projects for your GitHub portfolio. Start with the Titanic dataset, then pick 2 or 3 more that interest you. For each, write a comprehensive Jupyter notebook and a clear README. Deepen your SQL skills with joins and subqueries on HackerRank or LeetCode. By the end, you'll have a tangible portfolio and real skills. Consistency is key. Keep moving forward. It's easy to look at experts and feel a sense of distance, but every one of them started where you are now. Every expert wrote their first line of code, struggled with variables, and learned the basics. The journey is a marathon of small, consistent steps. Success isn't about brilliance, it's about persistence. Write a little code each day or tackle 1 tutorial a week. There will be days you feel stuck. That's normal. Learning to code is learning to solve problems, including the problem of being stuck. Embrace being a beginner. Be curious. Ask questions. Celebrate small victories. Your first working code, your first chart, your first project. Don't compare your chapter 1 to someone else's chapter 20. The goal isn't overnight expertise, but steady progress. You have a map and your first steps. The world is full of fascinating data and questions. Open your first tutorial, write your first line of code and start. The journey begins now. Welcome to the conversation.